right, today we're going to be talking about adding and subtracting with scientific notation. So when we add or subtract, we want to make sure the powers of 10 are the same. That's your first step, to make sure that the exponent on the 10 in both numbers is the same. Then we're going to add the factors. The factors are like the part that you're multiplying by the power of 10, the first part of the number. And then we're going to keep the powers of 10 the same. And then we'll look at our answer, and if it's not already in scientific notation, we want to put it in scientific notation. It'll look something like scientific notation, but we just want to make sure that that factor, the first number, is between 1 and 10. That's what makes it qualify as scientific notation. So let's try this first problem. We have 3.4 times 10 to the fourth plus 4.2 times 10 to the third. Well, those powers of 10 are different. The first one has a 4 and the second one has a 3 for the exponent. So first we want to make them the same. Well, how do we do that, and how do we know which one to change? Well, first of all, it doesn't matter which one you change, you'll get the same answer. So let's just go ahead and make this one have a 4. So we'll keep this the same. And then we have to think about, like, where are we going to put the decimal? Where are we going to move it to so that it becomes times 10 to the fourth? So what I like to do, and maybe this isn't the best way, but this is how I do it. I like to see what I would end up with if I moved the decimal 3 places over, because that's what the number says to do. So I'd have like another 0 on there, and it would be 4,120. So if I wanted to change the exponent to a 4, that would mean I'd move it over one more place. 1, 2, what made a straight line? 1, 2, 3, 4. So I would want to put the decimal in front of the 4 so that those are equal. If I move the decimal over in the original number 3 places to the right, or 4 places to the right in my new number, both times I would end up with 4,120, the same number. So I know those are equal, so I can change it and not change the value of the number. All right, so I'm adding these. We've now done step 1 only. So we're gonna add the factors. So remember, the factors are these numbers in front. And you can use a calculator if you'd like to do that. So I'm gonna punch those into my calculator. 3.1 plus 0.412. And I get 3.812 times 10 to the fourth. So I've done the next 2 steps. Now I'm just going to make sure that my answer is in scientific notation, and this time it is. I know it's in scientific notation because this first part is a number between 1 and 10. So that's how I know that I have it already in scientific notation. All right, let's try the next example here. I have different powers on my 10. So I need them to be the same. So I'm just going to change the second one. It doesn't matter, again, which one you change. I just usually change the second one, but there's no real reason. So if I were going to move the decimal 2 places over, I would get 100.4. But I want to change it to a number with an exponent of 4 on the 10. So I want to move it over 4 places to the right, which means I need to compensate for that by moving it 2 places that way. So now if I move it 1, 2, 3, 4, I still have 100.4. So those are equal. This time I'm going to show you how to set it up vertically, if that's something that works better for you. It doesn't matter if you do it horizontally or vertically, but if you want to set it up like that, you're welcome to do it that way. I guess I probably, if I were really going to do this correctly, maybe I would spread that out a little more so that you can see that you're supposed to add together this part. All right, and then actually that's easier to do by hand. Oops, that's not a pen. 4006. Nope, I didn't line them up right. 156, and then keep the decimal, or keep the exponent the same on the 10. Doesn't really look like an exponent. Let me make it a little higher. All right, that would be my answer because it's already in scientific notation. All right, so hopefully when I do the subtraction examples, we'll have one that we have to convert to scientific notation at the end so you can see this last step here. Moving along, guess what? The steps are the same, almost, except for adding or subtracting, but we're going to make the powers of 10 the same. We're going to subtract the factors. Those are the first numbers before the multiplying by the power of 10. We're going to keep the powers of 10 the same. And we're going to put the answer in scientific notation. That does not spell scientific. These are not professional videos. If I make a mistake, I just keep going because I don't have time to do them until they're perfect. So it's kind of like being in class, taking a math class from a human who makes mistakes. So hopefully you're all following along just fine. All right, let's try this example here. We have a power of 4 and a power of 3. The only thing that's really different than the problem before is now we're subtracting. So I'm going to keep this first one the same, and I'm going to change the next one to a power of 4 because I want them to be the same. So if I would originally move it 3 places to the right, if I put the decimal in front of the 8, now when I move it 4 places to the right, I end up with the same thing as the first number, and I'm going to subtract. So in my calculator, I'm going to do 7.4 minus 0.815, and I get another number that's between 1 and 10. Hopefully one of these examples will show you what I mean when you get an answer that's not already in scientific notation. Maybe the next one. So there's my answer. Okay, here's another example over here. I'm going to keep the first one the same. This is a little bit different than the ones we've done before, only because these are negative exponents, but we still want them to be the same. So I'm going to make them both have an exponent of -7. So originally in this problem, I would have to move it 9 places this time to the left, because with a negative exponent, that represents a tiny number, and we're moving the decimal to the left. That was my dog charging the laundry room door. Lily, come. Lily. Lily. She does not like it when the dryer's going. Come here now. Lily, come. Lily, come. Okay, good times. So if I was originally going to move the decimal 9 places to the left, and I want to change that 9 to a 7, that means that if I'm only going to move it now 7 places to the left, I need a jump start. I need to already start it 2 more places over. So I'm going to make it 0.08104. So you see how before I was going to have to move it 9 places from here, but since I've placed the decimal 2 places to the left already, I'll only have 7 more to go to get it to the number that it was before. And now we're going to subtract. So just like with adding, I'm going to subtract the 1.5 and the 0.0814. I can do that on my calculator. Which I'm doing right now. Oh my goodness, of course, the answer is in scientific notation. I just got lucky by changing the second number each time. But I think what I'll do for this example is let me go ahead and change the first one to match the second one and see if that makes a difference, so you can see what I mean by putting it in scientific notation at the end. So let me erase my marks up here. Okay, let's take this first one and make the exponent on the 10 a -9. So if I were originally going to move it 7 places to the left, and now I want to move it 9 places to the left, I need to put it back 2 spots so that when I move it 9 places to the left, it would be the same as moving it 7 places in the original problem. And then the second one I can leave the same. Oops, but I forgot to make that a 9. Okay, so let's do 150 minus 8.104. Since I'm doing these notes before the notes in class, I'll make sure that I do one of the examples so that we have to put it in scientific notation at the end. All right, and we're going to keep the -9. Okay, now you can see that my answer is not in scientific notation because this number is not a number between 1 and 10. So I need to convert this. It looks like it's in scientific notation, but the way we know it's not is because this number is not between 1 and 10. So if I put the decimal after the first one, now I have a number that's between 1 and 10, and I need to put a new exponent. So -9 means that I'd have to move the decimal from here 9 places to the left. But if I've already moved it 2 places to the left to get there, I'm only going to have 7 more to get to the right spot. So take a minute and notice the beauty of our answer because it's the same as the answer we got when we changed the second one. So I've shown you with this problem how it doesn't matter which number you change so that the exponents match, and I've shown you how to change the answer into scientific notation if it isn't already at the end. Thanks for watching.